The graphing polynomials. Polynomials at one variable are suitable to work with, as they give smooth graphs. In more advanced topics such as differentiation and integration, it is very important to have smooth graphs, as it is easier to determine the minimum or maximum of the graph line. If the graph represents a polynomial, these extremums represent the zeros of the polynomial. Let's consider an example involving the graphs of a polynomial. Example: the graph of the polynomial p, x, equals x cubed minus 3x squared plus 4 is shown in the figure in the following shown on screen. A. Identify the zeros of the polynomial on the graph. B. Check your solution by substituting the zeros found from the graph in the polynomial. Solution: A. Zeros of the polynomial represent the points where the value of the polynomial becomes 0, i.e. to answer the question, what is x for p, x equals 0. In other words, we must find the intercepts with the x-axis. From the figure, it is clear that the polynomial shown in the graph has two x-intercepts, i.e. two zeros, x1 equals -1 and x2 equals 2. B. Substituting in the polynomial p, x, equals x cubed minus 3x squared plus for the zeros found graphically yields, we have the following shown on screen. And, we have the following shown on screen. Hence, both zeros of the polynomial identified graphically are correct. That is all for lesson 11.2.9, and the end of tutorial 11.2. To continue this chapter, please watch 11.3, Introduction to Solutions for Polynomial Equations. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.info.